Hello guys, my name is Balkrishna Shivastav and welcome to CodeWithBK. So in this video, we understand the concepts that go behind where we have a pointer within a struct pointer in C program. So before we begin, it is a request to please subscribe to my channel. And if any of my previous videos or if this video has helped you out, so please subscribe to my channel. So we have this struct and we see when we create a pointer of this struct, how pointers within this struct pointer behave, what are the concepts that go behind. And we have a char pointer right now. We take an int pointer, we take an integer array inside, we see how things work. Okay. And I recommend watching the previous videos in this series that start with pointers, what are array pointers, what are struct pointers, how malloc works, how dynamic memory allocation works, and so on. Okay, till the point where we compare what is a struct object versus what is a struct pointer. Okay, so if I do something like this, I create a struct object. Okay, so we don't have objects as objects like object-oriented programming in C programming, but object is the most closely related word that we can use for a struct value. For example, if I have struct student s1, the type of this variable is struct student and the name of the variable is s1. Very similar to something like this. Okay, that the type of this variable is int, the name of this variable is j. So I usually go with the word object for structs and I go with the word value for primitive values. Okay, primitive types. All right, so we have struct student s1 and right now this is not initialized. Okay, so when you have something like int j, you basically in your memory get memory to store an int. Okay, and this memory is named as j. Okay, it stores an integer. The number of bytes that are needed to store an integer is given to this variable, and whatever the values assigned, we know it's a garbage value. Okay, because this is not initialized. Okay, contains some garbage value. Okay, similarly when you do this, you're creating a struct object, so you get memory for your s1, which is a struct student. Okay, so student has these three variables: int, char, pointer. So it gets memory for each of them. So it gets memory for int, okay, char, okay, and char pointer. Okay, and we have no idea what values are there inside, but this struct will get memory to hold one single struct object which contains these three. Okay, so my point of garbage values is if I try to print whatever the value is inside j. Okay, and I pass j. Okay, so j is some random value. Okay, some garbage value. We initialize it, the value of j changes, we know that. Okay, similarly if I assess the values in s1, they are going to be random, some garbage value, because we have not initialized them. Thus this just gives it memory. Okay, so when we say age is %d is s1 dot age. Okay, then we have grade and s1 dot grade. Okay, and I'm not going to print the value that is pointed by name. I'm going to print the address which this variable name stores. That is, I'm going to say name is, I'll print the value of the pointer, I'll say s1 dot name. A grade is char, right? So I'm going to say %c, or age is integer. Okay, so we get some random values. Age is some random value, grade is some character tag, this is blank or 0 that you cannot see. Okay, and then you get this is a hexadecimal value because 0x denotes as a hexadecimal value. So this hexadecimal value is basically the value stored in this variable name. Okay, because this is a char pointer, a pointer stores the address of a memory location, so it is storing the address of some memory location, because right now we know that all these three for s1, int, char and char pointer, age, grade and name, so you can take them as, so this is your age, this is your grade, and this is your name. Okay, the name of the variable, age is some value, char is some value, char pointer name is some value. Okay, and whatever this char pointer is storing, it is an address of a memory location which we are seeing here. Okay, so this right now is a wild pointer. Okay, so right now s1 dot name is a wild pointer because its behavior is undefined, because the memory address it is pointing to, we don't know what it is stored there. Whatever it is pointing to, we don't know that. Okay, that's why it's a wild pointer. This is very similar to saying in %p1. Okay, it means you get a variable the name of the variable is p1 of type int pointer. That is, it will store the address of a memory location, and the memory location should point to an integer. Whatever it is there right now, we don't know because this is not initialized. This is also a while pointer. Okay, and if I try to dereference this, that is get the integer at this location, I will get an undefined behavior. The program might crash as well. Okay, so I can say value at location pointed by p1 is dereferencing p1. We don't know how this is gonna behave. We might get some random value, or the program may crash. Okay, we got some random value pointing to some location. Okay, so just as this is a while pointer, okay, when you create a struct, this pointer inside the struct is also going to be a while pointer, because we don't know which address this is pointing to. If you want to use this, you have to make it point to a character. So what you can say is, now set the pointer in s1. So we say s1 dot name, okay, is now of type char pointer, malloc and size of char. Okay, and I can say s1 dot name is, say, it can point to one character, so I'm going to say a. So I'm now going to print the address that this variable stores, which is the address where this a is stored. Okay, so this address and this address is going to be different, because this was the garbage value and this is the address of the memory that we have provided to this. Okay, so, and I'll also print the value. Okay, value at name is %c s1 dot name, right? Value at s1 dot name. Okay, dereferencing the pointer. So clear, compile and run. Oh, okay. So basically you have to do it something like this. s1 dot name is basically a pointer to a character. If you want to dereference that location, we use star. Okay, this was a mistake. So clear, compile and run. Okay, so you see, initially name is this 1f, okay, and then name is this, because this was the default some garbage value. Then we gave name, okay, some memory. All right, we set the value at that memory to a, and then value at name came to this. If I try to do this value at name again, high chances, okay, danger, this might crash, because we don't know what s1 word name will dereference to, because we don't know which memory location it is pointing to. It's pointing to some memory location, we don't know what is stored there. So we try to get a character, right? We might get an error, a sec fault. So let's see. Okay, value at name psp give you some random value. Okay, then we get value pointed to by p1, which is some random value. Okay, because it's not initialized while pointer, don't use while pointers. Then name gets memory allocated dynamically to store one character. We are storing a at that location, and then we print the value at name, we get a. Right, so when we follow this code in our diagram, okay, we say s1 dot name is char malloc, so gets memory from the heap. So s dot under name was pointing to some location, now it is pointing to another location. Okay, because you see the values of the location changes. It was this, it became this, and at this location it gets memory to store one character where we are storing a. Okay, so character pointer in s1 is pointing to this a. All right, we don't have a variable for this location, but we can say this char pointer is pointing to this location, which is storing a single character a. So value at s1 dot name is a. Okay, so this is an example where we have a pointer within a struct object. Okay, if we have something like int marks and it is an array, so this is also an int pointer. Okay, pointing to a location, one single contiguous memory strip of location that has stored 5 integers. Okay, which means when you create a struct object here, you get memory for all its members, including this. So you get memory for 5 integers, 1 2 3 4 and 5. Okay, and this is your int pointer, the name, okay, and the name is marks, okay, some garbage values inside. Okay, so again if I try to print marks, okay, I guess some garbage value and I, okay, in this case when you create an array like this, you will get memory. You don't have to dynamically allocate it. This means that you are asking compiler to give me a memory enough to hold 5 integers, one contiguous single strip. So there is memory for 5 integers. So that is what I have shown here. But whatever values are inside, we don't know. They're all garbage values because just taken memory for this variable, this int pointer. Okay, so when I run this, I get some values. Yeah, you see I'm getting a danger here, okay, or probably here, wild pointer and wild pointer. Okay, this is also wild pointer, danger. This might crash because know what p1 will reference to. Okay, okay, so I guess we get segmentation fault because of this. This can also give us segmentation fault. It's just not giving, it's just giving me a random character. Okay, now we'll clear, compile and run again. Okay, so I commented this out. It's giving me segmentation fault again. This is also wild pointer. Do not have a wild pointer. Make it point to an integer or the first location of an integer array, or make it null. Okay, so the 4 marks that you get are some 5 marks you get are some random values. Okay, so you can initialize marks. You can say, okay, so you see I have to provide memory to this pointer name but not to this pointer marks. Okay, because we are declaring array using this square brackets, and here we just have a pointer. If you just have a pointer, you have to provide it memory before you use it. Okay, if you have something like array within something like an array using square brackets, giving it the number of locations, you can use it directly. Okay, because I'm setting the marks directly, not giving it memory separately, just as I'm doing with s1.name. Okay, so compile and run. Okay, I'm going to comment this out because this is also potential danger. Okay, all right, so the first thing is when you create a struct object something like this, just as you do int k, s1 will get, this object will get memory for all of its members. Okay, and if there is a pointer inside, it will get memory to store the address, and the address that it stores when you do this is some garbage value, and others are also some garbage values. Okay, when you do something like this, creating an array using square brackets, it will get its memory for those many number of locations. So it gets memory for 5 integers, and you don't have to allocate it separately. Just as in the case of name, you have to give it memory. For marks, you don't have to give it memory. So if you have gone through my video on array pointer, this will get a lot more clear. Okay, so you can use this directly without allocating any memory. You can use ith location because it has 5 locations. Okay, so you can set, you can assess, just as I'm doing here. I'm setting the values 80 plus I, printing the values, and you can set other values as well. So you can say s1.age. Okay, set s1 values. s1.age is say 18. Okay, s1.grade is say maybe. Okay, so if I set these values here, okay, okay, I get grade, this age as 18, grade as A, which I'm showing here. I don't need this. Let me just leave this out. I don't need this. And that rest all is what I need about this struct. Okay, all right, so this is when we have a struct. So similarly, if we have a struct pointer, if I say struct student, okay, student pointer p1, this is struct student pointer. Okay, a pointer to a student struct. Okay, not initialized. And what does it mean by not initialized is you get memory, okay, that can store an address which can point to a struct. So this variable p1 is of type struct student pointer, storing some garbage value, some address which I'm going to print, pointing to some location we don't know. We don't know if it is points to a struct. We don't know. Okay, it's a wild pointer. Okay, so this is also a wild pointer. Behavior is undefined. Okay, right, so let me just print the value. Okay, I'll say sp1, simply print sp1. So it will print the address that this variable sp1 is storing. Okay, so clear, compile and run. Okay, this address it stores, it points to this memory location. Okay, so if I try to get maybe age, grade, name, syntactically that is correct. So I say okay, sp1 dot age, sp1 dot grade, sp1 dot age, sp1 dot grade. High chances my program crashes. Okay, because the chances that it points to actually some struct student are very less. Okay, oh, it did get. Let me just try to print the name as well. Name is %p. Okay, sp1 dot name. Okay, so this pointer is not initialized. You should not be doing all this. This is just for demonstration. Okay, so clear, compile and run. Okay, points, this location points to this memory location. Okay, so the location where sp1 is pointing to, if I try to assess name there, I get this. Okay, you should not be doing this. You should always initialize struct pointer before using. Okay, so either you can set it to null, make it and use it later, or you can make it point to a struct. You can say sp1 equals to ampersand s1. Okay, s1 was the object name, right? And now if you print all this, okay, so it is going to, it is pointing to s1, so you get the same details, 18a, and this address you see is the same. Okay, or okay, you can say make this pointer point to an already initialized struct student object. Okay, all right, because you already had s1 here. Okay, so this means when you do this line, so sp1 was storing some address. Now it is storing the address where this is stored. This s1 is stored. Say this is stored at address addr1. So this is now storing this address of addr1, and this is a pointer to this struct. If we do something like this, okay, if we leave this out, so this is all gone. Okay, so this is still pointing to some memory, pointing to some location. Okay, all right, and then you can give it memory dynamically. Just as you give memory to this, you can say sp1, okay, is of type struct student pointer. Okay, give me memory enough to hold a struct student. Okay, now at least I am sure that this point, the variables in this pointer will have a memory. That is, when you do something like this, you have at least made sure that this will get value memory for all these four members. The memory this sp1 is pointing to is now a struct object, so it has memory for all its four members. So it has memory for your age, okay, some garbage value, grade, some garbage value, marks, has 5 integer slots. Okay, and name, some garbage value, which is a char pointer. So this is char pointer, this is int 5. Okay, and this is char grade, and this is int. Okay, but we just don't know the values. Okay, so doing this will give me some values but will not crash definitely. This might make the program crash. Okay, assessing members in a struct pointer which is wild, the behavior, the outcome is undefined. Okay, you should not be doing this. Set it to null, make it point to another struct object, or give it memory. Okay, all right, so clear, compile and run. Okay, some values, but there will be values definitely. Okay, this, oh, this is at 0, that's nice. Okay, now if you want to use this name pointer within your struct pointer, you have to provide it memory, just as you had to provide memory here. Okay, so let's provide it memory to hold an entire name. So I'll say sv1.name is, say my name can be a maximum of 20 characters. So I'll do something like this. Okay, malloc size of char into, say, 20. Okay, so when you do this now name points to a location, okay, the address of the first location of one single contiguous strip of memory that has 20 characters. So name now stores the address of the first location of this array of 20 characters. In other words, the value in name is say addr5, which is the address of first location of this memory. Address of first location of this array. Okay. So you see, in order to use a struct pointer, okay, this is just printing the pointer value. You have to first give memory to this struct pointer so that it points to a struct. Okay, this was a struct pointer initially pointing to somewhere, we don't know, so we give it memory. So you make sure that it is pointing to a struct. Then you make this pointer within the struct point to another memory location. You can surely use this pointer. Okay, now if I say I will use string function string.h. okay, so I will use strcpy. The destination is sp1.name and I will copy say Balkrishna to it. Okay, all right, and then I print sp1.name and I do %s. Okay, so this is gonna print my name. All right, so what did this was, we were here till this line. When we did this string was copied into name. So basically we had BALKRISHNA with a \0. Okay, \0 is automatically added when you do strcpy. Okay, so in order to use this pointer within a struct pointer, you will have to provide it memory. But if you want to use an array which was declared like this is not a pointer, this is the int pointer, but we declared it using square brackets, you can directly use this because it was given memory when you were creating a struct object pointed to by sp1. Okay, so you can say same thing, init marks. So you can say sp1.marks of I is I plus 90, and then you print. Okay, you say marks of I. Okay, compile and run, and you get the marks, the name. Okay, all right. So if you have a struct pointer that has a pointer inside it, if you want to use, you have to allocate it memory. If you have an array inside it, you can use it directly. You don't have to worry about freeing the memory as well. In this case, you have to worry about freeing the memory. So you have to free the memory for, you say free sp1.name. Okay, so the order in which you free the memory is in the reverse order. That is, this was provided memory at the last. Okay, so it goes out first. Okay, because it is within the pointer, and then you say free sp1. Okay, so the output remains the same, but there will be no memory leaks if you don't do this. Okay, so this was dynamically allocated and this was dynamically allocated from heap memory. It won't be given back. Okay, this is basically stack memory because this s1 is a local variable here. This is stack memory. Okay, I usually put all this in one single memory diagram so that it becomes clear to you. But dynamic memory allocation goes from heap memory. Local variables in a method go to stack memory. Okay, if you do this the other way, okay, what you are doing is you are clearing this memory. Okay, so when you clear this memory, this sp1 again will point to question mark. Okay, right now this is not pointing to question mark anymore. It is pointing to this location. So if this stores address is say addr say q, so this is also store addr q, some hexadecimal value. Okay, I showed you that the hexadecimal value changed. Okay, sp1 was initially sp1, oh, I did not show you, right? So sp1 wild pointer and sp1 after allocation. So you see the memory value changes after mem allocation. Okay, so you see these are two different values. So it was this, and then it took memory from the heap, so went to a different memory location. Okay, so this value that you see 146, this is basically this where this object is stored. Okay, and question mark was this value. When you free this, when you free sp1, this is given back to the heap. This variable is still holding this address because you are freeing the memory pointed to by this still has address q. So even if I free sp1 and I print, okay, after free, it will still be the same value pointing to the same memory location. It's just that we don't have any more allocated memory there. You see, this location and this location is the same. This is the memory location it got after memory allocation, and when you freed that memory, it is still pointing to that memory. It's just there is no more struct there, okay, because we freed this struct. Okay, then if you try to free sp1.name, the name is not there anymore, which is pointing to this memory. Okay, because this is gone, right? So all the members inside are gone. Okay, so there is no way we can access this memory location now, the address of this location now, because this name is also disappeared. That's why you free name first, so that this we can free, and then you free this struct pointer. So you should always free the pointers within the struct first before freeing the struct. Okay, that's why we do this first. And okay, all right, this location and this location will be the same. All right, so free the allocated pointers before freeing the struct pointer. And I mean, you cannot obviously free a pointer that has not been allocated. If I have, say, float f1, okay, we are not using this at all. So if you try to free sp1.f1, this is not going to be okay, because we have not allocated this. But this is dangerous. You do not do this. Again, danger. It is not giving you any segfault right now, but it may. Unexpected behavior. Okay, do not free the memory that you have not allocated. Okay, similarly, when we create arrays normally, right, int arr1 5, you don't free them, so you don't free these either. Okay, you don't say, there is no point saying free sp1.marks. Okay, there's no point doing this. And if you want to check this, you can try to free this. We have s1, right, the struct object that gets marks. So if I do my last statement, free s1.marks, there's no point doing this. Okay, pointer being freed was not allocated, so you comment this out. Okay, so summarizing this, if you create a struct object, okay, you get memory for all its members. Okay, if its members are pointers, they will have some memory addresses which will be garbage values. They all its member would be garbage values. So creating a struct will give you memory for all its members, then you'll have to initialize it. Got memory for its members, but then you have to initialize this. Age is 18, grade is A. So age is 18, grade is A, and marks were 80, 81, 82, 83, 84. Okay, and if you have a struct pointer, okay, struct pointer are basically variables that can hold values which are memory addresses that can point to a struct. When you simply create a struct pointer, it is a while pointer. It has some address, you don't know what it is pointing to, so you provide it memory first and then you use it. Okay, so that's why that address of sp1, where whatever value sp1 at this point is storing, is different before memory allocation and after memory allocation. Okay, so when you provide memory to this pointer, you are sure that it is pointing to a struct now, but again the values inside are all garbage values. So you create a struct like this, okay, or you create a struct using a pointer like this. They both have garbage values. You have to initialize them. Okay, so we initialize the values. Okay, and if there is a pointer within a struct and you're creating a struct using a struct pointer, then it has to get memory again like this. You have to dynamically allocate it, just as you have to do here in case of a struct object as well. Okay, so in other cases, in struct object or a struct pointer, the pointers within the struct have to be allocated before using. Do not use them before allocating. Okay, and then when you free memory, you free the memory dynamically allocated within this struct first, and then the struct pointer itself. Okay, so I hope this was clear. Better examples of this we do when we solve problems later, when we cover linked list, stacks, queues, and also trees, right? Okay, so this was it. The idea was to understand how a pointer within a struct works. We saw when we have a struct object, and we saw when we have a struct pointer. Okay, so I hope you like this video. This was helpful. So if there is any doubt, there's a part you do not understand, please let me know in the comments. I always try to answer all the comments, and you can also let me know in the comments if there's a question you want to solve, or if there's content you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.